So I wanted to do the second part of section 12.5 without using a computer. So what if, God forbid, the internet went out? Could we still do math? Yes, actually we can. It's been done for thousands of years. Another thing is, I'm going to do this problem in two completely different ways, and I'm going to get the same answer. At least, I hope so. So that's a very important point in Math 3C because there are times when you use vectors to solve a problem. Sometimes you don't use vectors and you can get the same answer. Sometimes one way is easier, using vectors. Sometimes not using vectors is easier, so it's good to have a choice. Okay, so for this example, where did two planes intersect? So one plane could be this piece of paper right here, and then here's another plane, and where they intersect is a line. So we're actually looking for the equation of a line. Now for this first solution, which I'm going to call A, I'm basically just going to use algebra. So what I could do is add these equations together. So when I do that, the y's are going to cancel. Right here, I would have 3x plus 3z is equal to 6. Or I could divide by 3 and get x plus z is equal to 2. Now, the thing is, I've got two variables right here, and I only have this one equation. So what I'll need to do is substitute it back into one of the other equations. The other small problem is, right here, I've got 3 variables, and yet only 2 equations. So what I could do is I could plug a number in for y. The only problem is I don't know what number to pick. I could say y equals 5, but the thing is, if it's a line, that means that eventually y is going to equal every value there is. So to remedy that problem, I'm going to let y equal the number t. And since t could equal any number I want, then eventually y is going to equal every number there is. Okay, so now take this, which I still need to solve for x. So take this and substitute it into the top equation. Also substitute in that y is equal to a t. So then the top equation would become, replace the x with 2 minus z, then replace the y with t. The rest of it would say plus 2z equals 2. All right, combining like terms. So that would leave z, and then subtract 2 from both sides, which actually is going to cancel this 2. And also I could add t to the other side, so it turns out that z is equal to t. And then take that and substitute it right here. So that means that x is equal to 2 minus t. Okay, I'm done. These are the parametric equations for the line of intersection. I'm going to put them in order. X equals negative t plus 2. Y is equal to just t. And z is equal to just t. Look at that. Basically using just plain old algebra, I did it. Now, if you look at this one, remember for the equation of a line, the number in front of t, the numbers in front of t, that gives you the vector. And that vector would be negative 1, 1, 1. Even though I didn't even use any vectors over here, it actually shows up in the problem. So this is the vector that tells you the direction, or in other words, it's the vector that's parallel to this line. Okay, that's one solution. Now, let's start over. Same question. Where did these two intersect? Well, for this one, if you take the numbers in front of x, y, and z, that will give you a vector. So that was 1, negative 1, and 2. Keep in mind this vector is perpendicular to this plane. So that would be like, if we're talking about the piece of paper, that would be this pen going straight up. It's perpendicular to it. This one's vector would be 2, 1, 1. Also, that one's perpendicular to its plane. Now, if we're looking for, let's say that this is one of the planes, and we're looking for the equation of this line. So if right now I have the vector that's perpendicular to the piece of paper, what I need is one that is parallel to the line. Well, if it's going to be parallel to the line, it's going to be perpendicular to this vector. So for this, I need this vector right here, that one, that's going to be parallel to the line. That means it's going to be perpendicular to this vector. So that means it has to be perpendicular to this vector. But at the same time, it has to be perpendicular to this vector. So what vector is it that's perpendicular to two given vectors? You're right, the cross product. So find the cross product. So here's I, j, and k. 1, -1, 2, 2, 1, 1. And then I like to speed things up by going like this. The first component, that will be -1 subtract 2. -1 subtract 2 is actually -3. All right, now cross off this one. That's going to be 1 minus 4. 1 minus 4 is a -3, but for the middle one you have to change the sign, so this is now a 3. And then for the k component, this is going to be 1 minus a -2. So that actually means 1 plus 2 is 3. Okay, that's the good news. We now have the vector that's telling us the direction of the line. So this is the correct direction. Now we need a point. So how do we find a point on the line? So at some point in time, z will have to equal 0, because if it's a line that's going through space, it's going to have every z value eventually. So at some point, z has to equal 0. So go ahead and put that 0 right here and right here. So this equation would just become x minus y equals 2. This equation would become 2x plus y equals 4. Then we've got two equations and two variables, so you could use elimination method to solve for x and y. So add those together, the y's will cancel. This is going to be 3x equals 6. So the point when z is equal to 0, turns out that x is going to equal 2. Then I could just take that and substitute it right here. And that equation is going to say 2 minus y equals 2. When you subtract 2 from both sides, it's going to say that y equals 0. So the point that it's going through is 2, 0, 0. So now that I have the direction that the line's going and a point that it's going through, I can create the equation of the line, the parametric equations of the line. So it's going to be x equals, y equals, z equals. And then you take these numbers and put them in front of t. So negative 3t, 3t, 3t. And then plus 2 for the x, 0 for the y, and 0. So that is my second solution. Now take a look at what I got last time doing it in a completely different way. Are these two the same line? The answer is yes. So this one's vector is negative 3, 3, 3. But notice that I could factor out a 3 from this. So it's also the same as 3 times the vector negative 1, 1, 1. Those are going in exactly the same direction. And if you look at the point that it's going through, 2, 0, 0, 2, 0, 0, it's the same solution. So I don't even need to graph it because I did it in 2 different ways, got the same answer. That means it's all good.